In some guided wave radar applications, Stirling wells can be used to help improve signal reliability. Let's examine some common designs and best practices for Stirling wells. In this example, the Stirling well is cut short and the weighted cable hangs below the bottom of it. In installations like this, the reading is unreliable because the return echo must travel back up through the end of the well. This is shown on the waveform as a very weak echo that is highly susceptible to outside interference, as the threshold needed to be lowered below the manufacturer's recommended settings in order to detect water. One thing to note, as the level of the water gets lower, the top of the weight begins to be seen by the transmitter. And since metal has a higher dielectric constant than water, the echo amplitude begins to increase. In the second design, the Stirling well runs the entire length of the weighted cable. This design is recommended as a best practice when utilizing Stirling wells for radar applications. The waveform in this example is extremely strong simply by increasing the well's length. In fact, the threshold had to be raised higher than the manufacturer's recommended settings to capture it for this video. In both examples, the Stirling wells were also unimpeded from connection fittings like couplings and tees. These types of fittings aren't recommended for any Stirling well construction. Also, any manufacturer will recommend the use of centering rings if there is a chance that the cable or weight may come into contact with the inner wall of the well. Lastly, in both cases the Stirling wells are metallic. If the material was plastic, the radar signal would pass through it as if it was not there. Therefore, plastic Stirling wells are never recommended for radar applications. Contact your local ABB channel partner for support on your upcoming guided wave radar installation.